Live on YouTube. So, good evening again. Our topic for tonight is swimming pool design, operation, and maintenance. This PowerPoint was originally authored and prepared by Engineer Leo Fajardo, who is an MEPF practitioner, also a civil engineer, mechanical engineer, and an electrical engineer. He is actually the son of uh, architect Max Pardo, also a master plumber. And I was able to get permission from Engineer Fajardo for this to be edited and updated and to be presented by yours truly. I'm Engineer William Jacinto, and I've been discussing this already at the MEPF training center in Quezon City before, but due to the pandemic, we now opt to present this via online, via YouTube, our YouTube channel. So we'll now proceed, and here is my short resume, and we'll have a short prayer. Our invocation. Namang banal, pinupukot ka namin at pinasalamatan sa mga biyaya at sa tuloy-tuloy mong paggabay sa amin. Maraming salamat po sa mga pagkakataon na makapaglingkod sa aming mga kapatid at sa aming bayan. Sana po magawain ito ay magbibigay ng dagdag na kaalaman, kakayahan at kaunlaran ng bawat isa at para na din sa aming bayan, Panginoon. At sana po ay ilayo mo po kami sa mga sakit at sakuna. Lahat pong ito ay aming tinataas sa iyo, dakilang Ama, sa pangalan ng iyong anak na si Jesus. Amen. So our presentation includes this table of contents. We have introduction, then number 2 is the types of swimming pools, number 3 is the components of swimming pools, number 4 is the components of pool filtration system, number 5 is the design of the pool plumbing and filtration system, number 6 is the filtration types, filtration and types of filters. Number 7 is the swimming pool accessories. Number 8 is the sample design of pool filtration system. And number 9 is how to make the pool sanitary and attractive. And number 10, how to ensure that your pool is electrically safe. Okay, so here we have this slide which shows us a swimming pool, which is as you see, it's almost totally enclosed, no? Inside, no, there are not much of a setback, so you can construct it even with limited space, depending, of course, on the owner. Okay, and when you construct it, you can also include amenities like in this slide you would see it, no? And of course, it also is consist of the structural, which is very important because the pool contains a big volume of water, so the pool must have structural integrity, so that you will be assured that there will be no cracks as time goes by when your pool will be in use. Okay, so as you could see this here, the so many rebars that are already provided, and of course the piping that are already included, and of course maybe these people are working for the grounding, the connections, and of course they will soon be pouring their concrete, which should be, of course, monolithic and properly poured and with vibrators, so to ensure that it is spread evenly. Okay, so introduction. A swimming pool is a man-made container filled with water intended for swimming or other water-based recreation. It can be above ground or in ground and made of wood or plaster or bricks. Could be metal, could be concrete, could be also be plastic like fiberglass lining, and here is fiberglass. Okay, types of swimming pools. We have the commercial type, like the resorts, the hotels, and the parks. And letter B is private, also residential and schools. And letter C is competitive, so for competition, just like the one they use in the swimming competitions. No? So it can be the standard gutter type of different shapes, no? Like the one on the left. And the gutter is here to collect uh, the tap water, no? And could be a skimmer type like this one, okay? And rain flow type like this one, okay? And low stone covered canal can be like this one. And infinity pools. The infinity pools usually you allow the water to fall on the end of the pool, so it will look like infinite or infinity, like this picture shown. And then above ground type like this one, so you would see that the tank is above ground and then just being provided with the platform at the same level as the top of the pool. Components of swimming pool, we have the structural shell, letter B, the structural shape, size, depth, and finishes. And letter C is the balance tank. Letter D is the plumbing and filtration system. Of course, here is just a schematic showing the various components of the swimming pool. Let us start at the right hand or the middle and right here. So we have here the return outlet, and then here is the water line, and then here is the main drain, the bottom, where you have the pipe here going to the infeed of the pump, okay. And here is also the skimmer, so the excess water goes to here. And then here we have the two-way valve and the heater. This box is inclusive. And then of course here we have a three-way valve. Here the three-way valve, the pump, and which is motor driven, the circulating pump or filtering pump, and the filter here. Then what else? The backwash, drain backwash here, and the control valve here, and the return inlet here. So in general, that's how a basic swimming pool looks like. And for a lesser or a more basic drawing showing the swimming pool with let us see, a width of 5 meters, and no, the length is covered, so maybe the length could be something like let me just scale it, so maybe about 12 to 15 meters in length. Okay, so 5 meters by maybe 12 to 15 meters in length. So anyway, so there is a scaling here. Okay, so you would see on the left side here the steps, and then the sloping floor to this deepest portion, which is about 6 feet. In here it's 4 feet, and on the other end is 5 feet. So that's the cross section, no? It's up to the designer, but this is the general layout of a basic rectangular formed swimming pool. Okay, and here is another one, which is let me check the length. I cannot see I cannot see the length and the width, but anyway, so and there are the pipings in here, and the floor drain, the inlet. You have piping to the filter, piping to the pump, and what else? And the piping for the inlet, 38 diameter PPR, and of course, oh, that's different. Okay, so And here is the pump room, where on the right side here is the pipe from the pool. Here, the pipe from the pool, 38 diameter, diameter PPR. And then here is the 38-inch diameter PPR pipe from filter to the pool. So that is the one going to the pool, and this is the one coming from the pool. Then here at the bottom is the filter room. Call out. And then here you have the pressure gauge on this tank. And then the cartridge water filter, 50 gallons per minute capacity, flow rate. 2 horsepower high-speed pump. It mentions about the brand Myers US. And here we have a gate valve, then another gate valve here, and the strainer basket here. So strainer basket at the outfeed of the discharge of the pump. Okay. So number 4, components of pool filtration system. We have the plumbing. Letter A, plumbing is considered the nerve of the pool, where your water is flowing. No? Number 1 here is main drain, the deepest portion of the pool. Then number 2 is the vacuum, 0.2 meters or 0.3 meters from the top of the water line. And number 3 is the skimmer, which is 0.1 meter to 0.15 meters from the water line to center of opening, and 0.2 meter to 0.2 meter from the edge of the pool wall. No? Return to pool, 0.2 meter to 0.25 meter from the water line. Floor return to pool. Then number 5 is the backwash drain, and number 6 is the overflow. Here are pictures of the floor drains. Here, so okay, and then here are pictures of the floor return. Okay, and then the return fitting on the right side. And skimmers. These are the skimmers provided on the side of the pool, very near the edge. And on the right side is a sketch of the skimmer here. Okay. And the vacuum. Okay, this is the vacuum. And for a spa and jacuzzi, we have here some samples of the cross section of the jacuzzi tank. Okay. Top view here on the upper portion, and a section on the below portion. And here is the also a sketch for a hydro massage head. Okay. Number 5, design of pool plumbing filtration system. Hydraulics, the basics of pump filter sizing. Hydraulics is the study and understanding of the behavior of liquids at rest and in motion. We are concerned with water, and we have the following 4 characteristics of our application. Number 1, or letter A, how much water do we have? So we must know the pool capacity. How fast do we want to move the water? This is the turnover rate. How fast you're going to turn over the water in the water going to the filter, to the pump, and back to the pool. No? How much resistance will this water meet while moving? So the piping will be the size of the piping, and the number of fittings will, and of course the strength or the capacity and flow rate of the pump will determine this. Okay, so because if you have so many fittings, elbows and T's, and if the lines are too small, then definitely your friction losses will be higher than usual, and you will be needing a pump with a higher capacity. No. And last but not the least, how will we overcome this resistance? Pump, filter, and of course the line sizing. Okay, so following are the step-by-step instructions to answer these 4 questions and ultimately determine the proper size of pump and or filter for virtually any aftermarket installation. Each step is a calculation based on the following example. 5 meters by 10 meters rectangular pool, 0.9 meters to 1.5 meter deep with an existing 1 horsepower pump. Filter gauge reads 10 psi, clean psi, okay? So pool capacity, to determine total gallons, we must first calculate the surface area of the pool in square meter. So it could be like this irregular form, just like the silhouette of a bin, and could be a circle or it could be a rectangle. So the area formula for this would be as indicated here: a plus b times the length times 0.45. For a circle, of course, is pi r square, or pi times diameter over 4. Diameter square over 4. Okay, and if rectangular, of course, length times width. Okay, and then surface area is 5 by 10, so 50 square meters. Sorry. Next, multiply the square meter by the average depth to determine the approximate volume of the pool. Okay, so here is the formula. Okay, depth at the shallow end plus the depth at the deep end equals, divided by 2 is equal to the average depth. So example, 0.9 plus 1.5 divided by 2 is 1.2 meters. Okay, so the tank volume is surface area in square meters times the average depth is equal to the volume in cubic meter. So 50 is the area, square meters, times 1.2 meters is the average depth. So your volume is 60 cubic meters. Pool capacity, cubic meters times 264.171 gallons per cubic meter is equal to the equivalent gallons. So pool capacity therefore is 60 cubic meters times 264.171 gallons is equal to 15,850 gallons. Okay, why do we have to go to gallons? Well, because most pumps, especially we are standard British standards, American standards in gallons, no? Okay, so turnover rate. Once the pool's capacity has been calculated, the next step is to determine how fast the water must be circulated in gallons per minute, or GPM, to meet reasonably clean, safe water standards. The recommended minimum standards for swimming pools are not less than the flow rate to provide one full turnover of pool every 12 hours. So that means that you have to turn over the water in the pool twice a day. Okay, in 24 hours, so twice. However, an 8 to 10 hour rate is quite common. So in other words, some owners here in the Philippines would turn over their the water in their swimming pool a little faster than the twice a day. Why? Because maybe our condition here is sometimes it's the air contains dust in the wind, maybe, so it makes the pool dirtier. So therefore there is the need to make the turnover rate more often. Instead of 12 hours, you make it 8 hours, to 8 to 10 hours. Okay, so turnover rate in gallons per hour in GPH is just simply the pool capacity divided by the desired turnover hours. So we were talking earlier of 12 or 8 or 10. So you will be able to get your gallons per hour. So therefore, turnover rate is equal to 15,850 gallons divided by 10 hours. So 10 hours is selected, is equal to 1,585 gallons per hour. Okay, turnover rate in gallons per minutes. Okay, so turnover rate in gallons per hour divided by 60 minutes is equal gallons per minute. So 1,585 per hour divided by 60 is equal to 26 gallons per minute. So now it's becoming clearer how big your pump is. We should be near this 26 gallons per minute. Friction loss. Everything that the water must pass through within the recirculating system, plumbing and equipment, creates resistance or head loss. The sum of all the resistance is called total dynamic head and is measured in feet of head. Okay, so computation is friction loss, vacuum is in inches of mercury, is times 1.13 feet of water is equal to so many feet of water, which is the total resistance. Okay, vacuum reading. Or common head loss factors, vacuum at pump minus assumes 2-inch suction line not to exceed 40-inch long. Minimal fittings, 1 2-inch valve and full rated pumps. 3/4 horsepower pump is 4.5 to 5.5 feet of water. And 1 horsepower pump is 7 to 9 feet of water. Okay, so that's the... Or a bigger pump, 1.5 horsepower, is 10 to 12 feet of pressure of water. And 2 horsepower pump is 13.5 to 16 feet of pressure of water. So total resistance vacuum is 9 feet of water for the existing 1 horsepower pump. Okay. Friction loss in PSI filter clean is 2.31 feet of head per pounds per square inch of PSI. Feet of head. So therefore, total resistance pressure is 10 PSI times 2.31 or 23 feet of head. Total dynamic head is total resistance vacuum plus total resistance pressure equals total resistance to flow, or blank feet of water plus blank feet of head is equal to blank feet of total head. Total resistance to flow is 9 foot of water plus 23 foot of head equals 32 feet of head. Okay. The table below provides a maximum flow in gallons per minute through a 1.5 inch and 2-inch PVC pipe without exceeding the maximum standards for velocity in feet per second. Example, suction line is 8 feet per second and the return line is 10 feet per second. So here we have the pipes. 1.5 pipe, suction is 50 gallons per minute and the return is 65 gallons per minute. For a 2-inch PVC pipe, the suction is 85 GPM and the return is 105 GPM. And for a 2.5 inch pipe, it's 125 GPM and 150 GPM. So we were able to compute earlier 26. So it seems like this 1.5 inch pipe is okay. So to recap, we now have all the information necessary to select the proper size of pump and filter. To recap, enter the final calculation from the previous 3 sections in the spaces below, which will see as our roadmap to sizing. Full capacity, we got it already, 15,800 something gallons. Then turnover rate, we got it already, and friction loss is 32 feet. So 15,850. Turnover rate computed is 26 GPM, and the friction loss is total is 32 feet of head. So looking at this table of this Myers pump sizing, since the one and only function of the pump is to overcome the total resistance to the flow of the system, proper selection is of utmost importance. The pump performance data is to provide in GPM or output versus the feet of head. resistance. See the table at left for the specific performance data for Hayward pumps. So this is Hayward pumps, not Myers. No, the other drawing earlier is Myers pumps. So here, let us look at this pump data here. So on the first column is model number maximum rated. So SP2600X5. The next line is SP2605X7, SP2607X10, and so on and so forth. And here we have the model number full rated here in the second column. There is no one on the first two lines. And here now is the pump output in GPM. So remember, our computation was 26 GPM. So therefore, this first column here, this first column, we have 55 GPM, and then 67, then 85. But look, our head is 32, so it must be therefore after here, no, between 30 and 40. Between 30 and 40. So here in 30 is 45 GPM. Okay, but if you go to a higher pressure, it's 29 GPM. So okay, so therefore this first unit is because the figure is in between 30 and 40, between 30 and 40, so most possibly 45 will be okay. Let's see. Now here, filtering size, model S180T, S210T, and so on and so forth, and the effective filtration area 1.75 square foot, 2.2 square foot, 2.6, and so on, no? And here is the design flow rate is 35 GPM. I think this one is more than enough for our requirements, which is 26 GPM. So this is smallest filter could be enough. Okay, and the turnover rate here is for 8 hours is 16,800 gallons. No, for 10 hours is 21,000 gallons. So again, our computed GPM is only 15,000, less than 16,000. So I think this one is good. No? Let's see what is being put in here. No, a filter, be it DE, meaning diatomaceous earth, is a kind of filter, diatomaceous earth. Sand filter or a cartridge type. So there are three types: the diatomaceous, the sand filter, or the cartridge type. So has a design flow rate in gallons per minute, as well as turnover rate, full capacity in gallon. See the table at left for the specific performance data for Hayward filter. So let's see here. Select S180. So as I said, S180 is acceptable, no? Select S180T minimum to adequately filter pool. Example, 26 GPM, 26 versus 35 GPM. So the specs, the capacity of this filter is 35 GPM, but our requirements, our computed flow is only 26 GPM. So this one is more than enough for our needs. So turnover rate will handle pools up to 21,000 gallons in 10 hours. This one, and we need only 15,000 something. One additional factor to consider in filter sizing is the Waither's load. BCR pools require larger filters. Also, larger filters require longer cycles, reducing the everyday maintenance required by the consumer during the fall season. Okay, so I think there is already an allowance from 15,000 something to 21,000. Summary: using the information in the recap section above, based upon your calculations, choose the desired pump and or filter model, then select the proper size component to meet the needs of the installation. It is important to remember that your turnover rate calculation is keyed directly to a specific total dynamic head calculation. Example, gallons per minute versus the feet of head. If you increase or decrease the flow rate, the gallons per minute rate for any reason, your resistance will increase and decrease respectively. Okay, so let us go back to that. So in other words, when you enlarge your pipe, instead of 1.5, maybe you're going to use 2 inch, then that means your resistance will be lower, and therefore you can also reduce the GPM capacity, and also that will make your less work for your pump. Okay, if you use a smaller pipe, then again your friction will be much higher. Okay, so let's now go to number 6, filtration and types of filters. The importance of proper swimming pool or spa filtration cannot be overstated. The reasons for filtration: to remove the insoluble matter such as dirt and algae, and to help produce clear, sparkling water, are obvious. Clear water not only looks beautiful, but it is also necessary for health and safety reasons. Many of the materials suspended in water are derived from the plants and animal sources, which provides food for bacteria and algae. It is these materials that must be removed if a pool or spa is to be maintained in a safe and sanitary condition. The 3 most popular types of filtration currently in use in residential pools and spas are high rate sand, number 1. Number 2 is cartridge type, and number 3 is the diatomaceous earth or DE. Okay, so here you have the sand filter, then the cartridge type, and the diatomaceous earth. Okay, high rate sand. When you say sand filter, it is the oldest and most popular method of filtration. Sand filters share 2 things in common. When in the filtration mode, water always flows from top to bottom. They all have some sort of lateral or under drain with slots to hold back sand while allowing clean, filtered water to pass through. High-rate sand filters use a special filter sand, normally 0.45 to 0.55 mm, also known as pool grade number 20 silica sand, because it has sharp edges that serve to separate particles, allowing filtration to take place. They operate on the basis of depth filtration. Dirt is driven through the sand bed and trapped in the minute spaces between the particles of sand. Initially, a clean sand bed will remove larger particles, and then as the bed starts to load up, it will remove finer particles. This is a picture or a graphics of a high-rate sand filter, and here is another one showing this filter. And you have here, this is the filter, and here is the pump, the water pump, and the corresponding piping. The cartridge type. The cartridge filtration has been available for a relatively long time, but only recently has begun to enjoy rapid growth and acceptance. When water passes through a cartridge filter, dirt is screened out of the surface of the cartridge element. When clean, the element will trap larger particles, with finer particles being filtered out of the pores of the element, become clogged by larger debris. The cartridge element can be removed and cleaned by pressure washing inside and outside using a garden hose. So that's the cartridge type, and this is the picture of the cartridge type. Okay. And the third one, diatomaceous earth or DE. Many pool professionals consider the DE filtration to be the finest because it is capable of removing smaller particles than either sand or cartridge. Diatomaceous earth is a porous powder with microscopic openings that, when magnified, looks like a tiny sponge or a tiny sponges. Clear water can pass through these openings, but particles as small as 1 to 3 microns are trapped in the first pass through the media. All DE filters have internal elements that become coated with DE powder. It is this filter cake that strains dirt, dust, algae, and some forms of bacteria from the water. Similar to sand filters, when a DE filter becomes dirty, it is cleaned either by backwashing the clogged DE to the waistline or regenerating and draining. To restore filtration, a fresh charge of DE powder is added to the filter. Okay, and here is a picture of the DE filter, which is what's mentioned as the most common for the professionals. And here is a simple diagram showing the piping. Here is the suction part of the pump. I have here a check valve, and then the pump here, and then here again you have a check valve here going to the direction of here, and passing through the filter, and then here passing through here another check valve going to the pool. Okay, this B valve here is a here in the middle here is a valve that is used for backwashing. No, if you want to clean or backwash the filter, you just close this F2 filter. Close this F2 filter, and of course you will move the water here like that. Okay, here like that here, and this close, so it will come back here. And of course this is open. I'm sorry, this is open, this is closed, and this is open. So the water there would be pumped through here, go to the filter, and will go to the waste. Then during operation, this is closed, that is closed, this is open, this is open. Okay, so that's how the piping of the swimming pool is arranged. Okay, technical data in filtration. So here we have the three filters as compared. Filtration method, the higher rate sand filter, and then the cartridge filter, and the DE type filter. For residential, GPM per square foot here is 20, and for commercial is 15, and for microns capacity is 20 to 40 microns. Okay, so that means that let's see the cartridge type, 1 GPM per square foot, and here is 0.375 GPM per square foot, and 10 to 20 microns are trapped, no? But the DE, take note, is 2 for 2 GPM per square foot, and here 2 GPM also per square foot for the commercial. But take note, it will trap dirts of the size of 1 to 3 microns. So therefore, the DE type filter is the most capable. 1 to 3 microns, as small as 1 to 3 microns are removed or trapped. No? While the cartridge have larger dirt, it's larger, so it allows more dirt, and of course much more with the sand filter. Okay, so among the three, therefore, the DE is the most efficient in terms of filtering. Swimming pool accessories. We have here the grab rails. The grab rails must be mounted securely. So as you can see here, before it is being finished, the piping must have been connected to the rebars, welded, so that when the tiles finishing are being accomplished, it would be very firm or strong. Okay, and pole lights, of course, the pole lights, and the slides if you want, and here on the right side is the falls or fountains. Here is also falls, and on the right side is fountains. And here another sample of a fountain on both sides of the pole. Okay. And here are float lane dividers, and of course some starter platform. So this is for competition. And water sanitation. So now here you have you see the filter tank and the pump here below. The black one is the pump. Okay. So traditional chlorine is used for sanitation. The electronic ionizer automatically sanitizes your pool by converting the salt in free chlorine into free chlorine, which kills the bacteria and algae in the pool. So it is salt that is being added, which converts it to free chlorine to disinfect the water in the pool. Here is a picture, and then here is another picture. The filter tank here and the pump here. Okay, and these are the electronic salt chlorinator here on the right side. 20,000 gallons for the left and 40,000 gallons on the right. And here is just another installation diagram for the electronic salt chlorinator. So you have here the pump, then the filter, then here is the heater, then electrolytic cell, then flow switch, and then goes to the pole or to the spa. And from the spa, here was coming from the pool, okay, to the pump, again to the pool. What is this solar system? So if you have a solar water heater, so it could also in other words, could also be used to heat your water instead of using electric water heater, no? So when you use solar system of water heating, then you can save energy. Okay, here are some detailed samples of the installation. And pool heaters. You could see here this box on the left side is a mechanical heat pump. This mechanical heat pump can also be used to heat the water in the pool. So here is the tank filter, and here is the pump, and here you have a strainer, and here of course the mechanical heat pump. By the way, mechanical heat pump is much more efficient, consumes lesser electricity in being able to heat your pool water as compared to that of a water heater. A water heater really consumes too much electricity. So therefore, your options are mechanical heat pump or rooftop water heater, solar water heater. Here is a sample of the the mechanics of a mechanical heat pump, how it heats the water. So the cold water comes in here, and then passes through here in this tank, and then it will come out from here as a warm pool water. No, of course this mechanical heat pump make use of the warm air in the ambient, passing through here, there, going out here at the top to the heat in the warm air comes here to this heat exchanger here, this radiator like thing here, and then of course transferring the heat, the ambient heat in the air to here, no? Okay, so sample design of a swimming pool filtration system. So now we are already in number 8 here. So we have done this earlier. We are just showing it in sample calculation side. Of course, this one now has a bigger volume, no? 6 meters by 12 meters long, 6 meters wide by 12 meters, and 1.5 meters deep, so 108 cubic meters. Balance of tank is 1.5 by 1.5 by 1.5 or 111.375 or 111.375 cubic meters times 1,000 liters per cubic meter, you get 27,843 gallons. Number of hours the pump runs in one day, so say using 8 hours, so 27,843 divided by 8 hours, you get 3,480 gallons per hour. Divide by 60 minutes, your pump will be 58 gallons per minute at 6 hours a day running time. And then here, okay, sorry, let us go back to that. At 8 hours it is 50. So at the next is at 6 hours, so 27,843 divided by 6 hours, you get 77.34 GPM. Okay, and then turnover rate at 4 hours will be what? 116 GPM. Okay, based on the table above, the desired flow rate needed for the pool at 8 hours turnover rate is using the DE type, the DE3620 T2 and the DE4820, 6 hours running time. So here is a picture of that. Okay. And there is a blown out picture of that filter here again, with the specification here on the left, and here is a blown up again of that. This is the next one, a larger one, and this one also a blown up of that one, larger. It's almost the same. And the pump, based on this table, we will use a 1 horsepower pump motor to couple with the DE filter. The output of the pump is lesser than the output capacity of the filter. A 1.5 horsepower pump is also applicable for a 40-foot head loss. So here is a picture of that Hayward pump. So pipe sizing, suction line, recommended water velocity 6 to 8 feet per second. Return line, recommended water velocity is 10 feet per second. So for a 6 foot per second speed, then 1.5 pipe, 38 GPM. For 2 inch, 63 GPM, and so on. No? For 8 feet, becomes 51 GPM and higher. No? For 10 feet, then larger capacity, 63, 105, and so on. Okay, so for spa jacuzzi, the heater is from 5 kilowatts to 11 kilowatts. For if you use gas heater, 150,000 BTU to 400,000 BTU. Blower is 2 horsepower. Hydrojet fittings, and then pumps, filters, plumbing, and accessories. And here are the hydrotherapy fittings at this portion. Okay, here, and there is the blow up of these fittings. And again, here is the tank layer. Is a 5 meters wide by 12 meters long tank. Okay, that was the one earlier that was shown. Design of rim flow canal. Water level is at the top of the pole, coping and Lost River stone canal covered. Here, so you have here the Stone River around the pool, no? Okay, now how to keep your swimming pool sanitary and attractive. But before we proceed to that, let's have a short break. Okay, let's have a short break. Okay, we're back. We're back. Uh, okay, let us greet those who are in our chat group before we proceed. Okay. Kent Molina is again here. Good evening, Sir Will. Good evening, Kent. And T. Hans. Kalimutan ko yung your apelyido. Good evening, Sir William. Yes, good evening. And then Alan J. Pantonilla. Good day. Then Ronel Calyanta from Singapore. Gandang gabi, sir. Good evening, Ronel. And then Arnel Ergisa. Good evening, Sir William. Good evening also, Arnel. And Marcelino Salazar. Good evening, Sir William. God bless you more. Thank you. God bless you too. And Alvin Mahaya. Good evening, sir. Good evening also. And John Docos. Good evening. Sir Will. Good evening also. And Rowell Bukatan. Good evening, Sir Will. Good evening likewise. So, by the way, and those of you who may want to get a copy of the PDF, just PM me in Facebook or leave a message. Si Marciano nga pala. Okay, nice to see you again, Marciano. Okay. And now we continue. Just post any questions so that later at the end of the presentation, I will try to answer all your questions. Okay, so now we go back to the slide. There. So now we are on how to keep your swimming pool sanitary and attractive. Okay, this is number 9 already. Pool maintenance. So in pool maintenance, you have the water chemistry, the pH balance, okay, the acidity of the water. Then number 2, the chemicals, your chlorine, your muriatic acid, decalite. Number 6, copper sulfate. Number 7, soda ash. Other products, counter current pool. So, okay. Water chemistry. Whatever method of filtration is selected, it is important to remember that filtration alone does not keep water looking at its best. Proper water chemistry must also be maintained for safe, clean water. Most pool owner complaints are directly related to water chemistry or improper sizing of filters and pumps rather than equipment failures. Chlorine. Chlorine is used as disinfectant or water purifier. Chlorine level must be maintained at reasonable limits, from 0.6 to 1.0 readings, to ensure that there is sufficient amount of adequately to disinfect the water, but not in excessive amounts, which will irritate the bathers. No? Apply chlorine preferably in the evening by hand, broadcasting it directly into the water. Acidity. pH, muriatic acid. The pH readings must be between 7.2 to 7.6 for comfortable swimming. The result of filtering makes the water more basic or alkaline. Apply acid 1 pint at a time by directly pouring it around the pool. Too much acid, low pH, causes irritation to the eyes and mucous membrane. Algae prosper and the pool gives off an unpleasant chlorine odor. In short, regular chlorine dosages to maintain chlorine readings at 0.6 to 1.0 and pH at 7.2 to 7.6 is all that is required to prevent the spread of algae and thus keep the pool sanitary and attractive. What to do? Maintenance is a matter of good housekeeping. Vacuum, clean the pool floor and brush sides thoroughly every morning. Apply chemicals in the evening and run the filter at least 4 to 6 hours daily. Okay, that's all there is to it to make your pool looking sparkling clean. Okay. Here we have pool gallonage, amount of chlorine and amount of acid. So for the 15,000 GPM, 3 to 4 ounces daily and 3 pints or 1.5 quarts If it is bigger GPM, then here, or 25,000 GPM, here. I mean, not GPM, gallons, no? So 8 pints is equal to 4 quarts equals 1 gallon. Above table is only a guide. Your water test kit will tell you when to put chlorine or acid to the pool. So always use the test kit before adding the chemicals. Okay, so now we were already able to make your water sparklingly clean. That's the maintenance. But look, in the old presentation, let's just go around this, how to make your swimming pool electrically safe. But before we go back again, let me just have a break, short break again. Okay, so we are back. Let us finish the. Let me just check on the. Okay, how to make your swimming pool electrically safe? How to check it? Of course, this is just a picture just to show that we are not supposed to play around with electricity in the pool. So this is not true. You should not put a convenience outlet floating on the pool. Not possible. So electric shock drowning severely injures, kills people. This is a comment from the NFPA. So therefore, electric shock drowning is possible. As you can see also in this picture, there was a camera in a pool in America where the camera was able to catch children being electrified in the pool. So therefore it is dangerous. And here is another grab from a newspaper news several years ago, which I was able to take note of. There was this building in Makati where people bathing were electrocuted. You can read the details in this news item by Victor Agustin. So therefore, we must be very careful in installing the electrical system of swimming pools. No, number one that is must be observed is the equipotential grounding. All non-current carrying metallic parts of the swimming pool system or ISPA, example, the stainless steel handrails, metallic chairs, or other furnitures that are metallic, lighting poles, lighting fixtures, metal casings, or motors or pumps, electrical metallic boxes, enclosures, etc. must be adequately grounded to the earth grid. So, the minimum ground resistance reading should be 1 ohm or less as measured by using a digital low resistance meter tester. And here is just a provision in the National Electrical Code, Bonded Parts of Electrical Equipment, Section 680.26, Part B and 6. As you could see, there is a pull here, and the railing it shows must be grounded to the rebars. So in other words, before pouring concrete, all of these metallic parts must be grounded to the rebar of the swimming pool tank. And in the pump room, as you would see here, all metallic parts here. Say the pump is a metal, made of metal, it must be grounded. Here you have a furniture, which a seat, or a diving board. I'm sorry, a diving board must be grounded also. So anything that is metallic in the pool must be adequately grounded to the rebars of the system or through ground rods. No? Here is another picture again showing that the rebars before pouring concrete are shown, and your ground here must be connected. See, you would see here number 8 WG copper connecting to the ground. Okay, and here is let's say a pull lamp being installed, and you would see the copper wire at the back of it being connected. Of course, connect it to the rebars of the swimming pool before pouring concrete. So here, again, you have rebars around the pool. So your railing here, and the stainless railing on the right side, must be sitting on the rebars before pouring concrete. So should be sure connected solidly, okay, before pouring the concrete. So here, any piping that is not plastic, it's good that in our country and in many in the world, they use the PPR as a means of piping. So if it's PPR, there is no need for grounding. But if you're using GI pipe or stainless pipe, or you are using copper pipe, you have to make sure that you ground all of these metallic pipes. Okay, ground them as shown in here. Even the sink in the bathroom of the swimming pool must be grounded. Everything, any metallic parts of the swimming pool must be connected to ground before any finishing is completed. This is to make sure that all metal parts are of zero potential. Okay, underground wiring. Underground wiring is not allowed under the pool or spa. Underground wiring may be run no less than 1.5 meters or 5 feet from any side wall of a pool or spa. There are some exceptions when wiring attaches to the pool or spa to serve equipment or lighting. When there is insufficient space in the area to maintain 1.5 meters or 5 foot separation, wiring may be closer, and it is installed in a complete raceway. Okay, so you can just go through these requirements. Then electrical outlet receptacles for pumps and motors must be located between 1.8 to 3 meters between 6 and 10 feet from the pole walls. Okay, so just follow this kind of outlets. Okay, must be provided with a GFCI. So remember that the code requires that all exposed circuits must be provided with a GFCI, ground fault circuit interrupter, or earth leakage breaker. GFCI protection. Most devices and equipment serving pools or spas and the surrounding areas must be protected by ground fault circuit interrupter or ELCB. Okay, that's it. And here is just how to show it. Here on the right side is an outlet that is with a GFCI, and here below are types or GFCI. Okay. Use of 15 volts rated or lower voltage for underwater pole lights is highly recommended. So you should not use 220 volts AC lighting or 110 volts AC lighting, but should use 15 volts or lower DC. Okay, so to make just above 100, like 110 volts and 220 volts, should be avoided. Okay, maintenance disconnect. A maintenance disconnect is required for shutting off power to the pool. So there should be a main disconnect. Okay, so in case of an emergency, you can go immediately to that main breaker and you can shut it off. Okay, so here is a picture of a maintenance breaker. This big box here. Okay. Okay, special regulations for self-contained spas and hot tubs. Outlet receptacles can be no closer than 1.8 meters or 6 feet from the hot tub. And ceiling lights, fans, and so on. So just when you're designing, just follow these requirements. And here are just schematics showing the system, the pipings. And any metallic pipe and metallic part here must be grounded. Okay. Overhead electrical lines. We should not allow any overhead line traversing above the pool or water tank. Utility power lines that run over a pool or spa must be at least 6.85 meters or 22.5 feet above the water level or base of the diving platform. Communications cable must be at least 3 meters or 10 feet above the water. So, better if you do not allow any, or if you construct a pool, there should be no electrical line above the pool. Thank you and God bless. This is the last page. Okay, so now we proceed to the chat box again. Okay, so here, let me see if there are questions. Mostly the messages are greetings. So here, Pale Pilsen, good evening, Sir Willie. Good evening, Pale Pilsen. Then to Engineer Marciano, God bless sir, God bless you too. So Dave Safred, good evening. Nice to see you here. Nestor, thanks again, Sir Willie. Another good lecture. Thank you, Nestor. Our partners in the Philippine Society of United Master Plumbers, Dave Safred of Lucena, Tayabas, and Nestor Reyes, our National Auditor of the Philippine Society of United Master Plumbers. Okay, Dave, nice and very interesting subject, Sir Willie. Thank you. Okay, ladies and gentlemen, I'll just give you 2 to 3 more minutes for any questions. Otherwise, we will now end this live stream. By the way, those known to be in the swimming pool construction business is one is who is very successful is architect Rick Taytay, who is also a registered master plumber, and he's also a member of the PISAM and also the Philippine Society of Plumbing Engineers. He is based in Cavite. And another one, of course, is Leo Fajardo. His company is Elecol Engineering. He has done a lot of work also. Many of those that I know that are making swimming pool seems to be earning money. They're making money. Of course, I don't know if there is if doing this business, swimming pool will still be okay after the pandemic. But of course, it is entertainment, and so the social distancing will still need to be observed in swimming pools. But of course, swimming in the sea, just like in Boracay or in the seashores, is good for the health. The seawater is known to be a sanitizing compound. You remember here, it mentions about maintaining the swimming pool using salt. So the salt is being converted into chlorine by the automatic chlorinating equipment. Here, Alan J. Pantunilla, maraming salamat. Yes, you're welcome, Alan. Okay. So, those of you who may want to get a copy of the PDF, just message me, or you can PM me on my Facebook account. So, or if you know my email, you can just email me so I can send you the PDF copy of this PowerPoint. And anybody who may want also to have a certificate of attendance virtually, then we'll also prepare if you want to. A question from Engineer Marciano. Sir, ilang pump ang kailangan kapag dalawa ang pool? Well, the practice usually is one pump per pool, but if you have two small pools, then maybe you can also have one pump for the two, but usually it would be uh, because you will be needing three-way bulbs to change the usage, no? You'll have using one pump, say you have to use these isolating bulbs in order to use it for one pool. Then after that, you will transfer the use of the pump to another pool. So you will be needing transfer or three-way bulbs, no? Transfer bulbs. While if you just put one pump each, then it will be much simpler for the operation. So the answer is more on the cost of putting two pumps, of course, no. Okay, question from Michael Pagulon. Sir, paano si Ronel, no? Maraming salamat, sir, for another learning. Take care. Yes, take care, Ronel, no? Michael Pangulom, sir, paano mag-size ng make-up water for the pool? Make-up water for the pool, well, you have to maybe calculate the evaporation. That was not included, of course, here. Make-up water usually is not a big problem, but let me add it na lang in the comments after the presentation. Okay, so but of course the make-up water is yeah, it's true, maybe the volume might be too much, no, but because of evaporation, mostly it's because of evaporation, because it should be just going around, no. Okay. Okay, Marciano, thank you. Yeah, welcome. Okay. Any more questions, gentlemen and ladies? Ronel, maraming salamat, sir, for another learning. God bless. God bless, Ronel. By the way, I hope you can organize your group there for the review class in Master Plumber for next year. So I know Engineer Lawrence in the chat group is already attending to your needs, no? Charles Ananayo, yes, Engineer Charles, more power also to you, to everyone. Okay, so please share this to your colleagues and friends. Share them my YouTube channel. We will continue to conduct this kind of free lectures here. Okay, one more minute for questions. So we're thanking let me go over Kent. We're thanking Kent Molina, Marciano, Alan Pantonilla, Ronel Calyanta, Arnel Argisa, Marcelino Salazar, Alvin Mahayag again, Jan Docos, Roel Bukatan, Pay Pilsen, Dave Zafred, Nestor Reyes, who else? Michael Pangulon, and Charles Ananayo. Okay, so seeing no more questions, let's have our closing prayer. In Father, Son, Holy Spirit, Amen. Lord God, we thank you for this opportunity again to be able to conduct this webinar, and thank you for those participants that we have here tonight, and also thank you also for those that will be able to see this when the YouTube will post it here after this live streaming. Thank you, Lord, for your continuous guidance upon us as we go through the new normal after this pandemic. I hope that you will always continue to keep us away from the sickness, keep us away from harm. Also our loved ones, our family members. And also, Lord, we ask that you also uh, guide us, guide our businesses, our endeavors, our work, the company we belong to today, so that we can course through these difficult times. Lord, we ask you this in the mighty name of your Son, Jesus Christ.